Hello and welcome to part 2 of my physics examples. Today we are looking at if you are trying to find the acceleration of an object on an inclined plane when you are given your mass, coefficient of friction, your first velocity where it's starting at a rest, so it's starting just sitting here, and your angle of 30. Now, as you can see, I didn't say you started with that, because that's, you don't start with it, but that's what you first do. You find your FG, which is your mass times gravity, which is the 350, the weight in this case, times 9.81, and you get that. For our case, this is not the case for every physics problem. And then you want to get your perpendicular and your parallel lines figured out, which is over here. You got your parallel one, parallel to that one. Obviously not in this case, I can't draw well, but it's going to be parallel here. And your perpendicular one, which is this one here. By the way, the angle here and here are going to be the same. That is going to be useful over here. For FG, this one, you're going to use the sine. It's opposite over hypotenuse, and it's opposite of that angle there. And then you would FG parallel over FG, your normal FG, the one we got over here. Move that to put that on its own. Put in your numbers and solve it. The next one's similar, same thing. FG, get it on its own. Put in the numbers. And then you're going to want to analyze your forces in the y direction. So Fy is equal to your Fg perpendicular. And since we have no actual acceleration in the y direction, it's in the x direction. And that's the one we're looking for. It'd be 0. And then you move that to the other side. So then your Fn is equal to your Fg. And then you're going to want to find your force of friction, so which is the one here. Because you're not pushing on it, so it's just going to be sliding this way, which means your force of friction is going to be that way. Sorry, I keep putting pencil on my monitor. Which is force of friction is equal to your E times your Fn, which we were given our E, which is 0.09 times our Fn. Sorry for the mess. MS Paint is awful. And then we'd get this here. And then you'd go to your final thing. Your force is at the x direction, so your Fx is equal to your parallel, which is equal to mass times acceleration in the x direction, which is just equal to your mass times your acceleration in the parallel direction, which means that you would get, and so you go to the next step, Ff minus Fg parallel is equal to ma, which is the acceleration you're looking for. This is different from that one, because that one's in this way. This one's in this way, the one you're looking for. You would then divide your m to get it over here. So you'd have Ff minus Fg parallel divided by m. You would put in your numbers, and you should get, for this case, negative 4.14 meters per second squared. So down that way. So to quickly run through again, you find the weight of it in the newtons. You would solve to get your parallel and perpendicular. You would get your forces in the y direction to get your Fn. You would then use that to get your Ff with your U, and then you would make the final formula by analyzing it in the x direction. Shoot. That's not a part of the math equation, physics equation. Get it in the x direction, you put in your numbers, and there you go.